Hello, my name is Sanjana Suresh, and I've worked with my partner Namisha Pant on our resume screening project, which I'm going to give you a demo of today. So, our project basically demonstrates two approaches to automate resume screening using NLP, which is natural language processing, and machine learning. And we have two notebooks, and both notebooks classify resumes as either fit and move forward with interview process or not a good fit. So the goal of our project was to use natural language processing and data analytics. We did this using the Z-score analysis to automatically screen resumes and identify top candidates from a large data set. The dataset used is from Kaggle's resume dataset. So we have a couple requirements for the project. You want to make sure that you've installed these libraries, and you also want to download the NLTK stopwords. The files in our project that we have in the GitHub include these files. We have the model1 underscore rb.ipynb. This is the file that uses the simple keyword threshold to label candidates. We have our second model, which is model2 underscore z-score.ipynb. This model uses a statistical z-score approach for a more adaptive labeling. And we also have the clean dataset.csv and keywords.csv, which I'm going to talk about in a second, but please make sure that you download those two before you run the IPYNB notebooks. So part one of our project was the initial setup of it all. So it started with data cleaning. So we imported the original dataset from Kaggle. So we downloaded it in a CSV file and uploaded it, and we had to clean this up. So we stripped off all the HTML tags, punctuation, and also numbers from the resumes. We converted all the text to lowercase for ease of reading, and we removed stop words using the NLTK, the download. And this has already been completed and done, and it's saved in that cleaned dataset.csv that is uploaded in GitHub. The original dataset, like I said, it's going to be in Kaggle if you want to take a look at it. We also have keyword scoring, which basically uses a list of relevant data science keywords from keywords.csv. So initially we debated using like a dictionary and putting in a bunch of keywords there and just comparing the resumes with the dictionary, because we are basically kind of screening for a data science project. So like we're pretending that we are a data science firm and what kind of data science skills we look for in a candidate. But then we decided that we wanted it to be more adaptive, and a dictionary wasn't exactly super adaptive, and it's also very limiting. So we made it a CSV file instead. For each resume, the keyword scoring counts how many keywords are present, and that's going to be saved as a keyword score. And this is also already completed, and it has been saved in keywords.csv. So when you want to run, we obviously have two models, so you might be a little confused on which model runs when. So if this is a hypothetical, if you are looking to hire more people, example, you are a small startup company, we recommend that you try the Model 1 rb.ipynb notebook, because I will go on why in a second. I'm gonna just talk about what's best to run for right now. If you are looking to hire few people, example like interns, and you're already a big established company, we recommend you try the Model 2 zscore.ipynb. And if you're an instructor or grader, which is obviously for this class, we recommend you run both notebooks so you can see both of our approaches. And I'm going to talk about why we decided on this approach specifically below. So for part two of the project, which is the actual model building and training, we decided that the first model, which is like the easier model we built, was going to be a rule-based threshold. Basically, any resume in the dataset with 3 or more matching keywords from that keyword CSV is a fit. And if there's not at least 3 matching skills in the resume with the keyword dataset, then it's not a good fit. And it's super simple and super easy to tune, which is why if you're a small scale company looking to hire more employees, this would be, easy because it's a startup, people might not have all that experience. So this model uses a text vectorize using count vectorizer, and we also use logistic regression to classify, and it's based on the cleaned text. So we picked a threshold of 3 keywords specifically in this model because it's a simple heuristic to identify candidates with basic relevant skills, and this number can obviously be customized based on your job requirements. And yeah, that's about the first model. For the second model, which is our z-score based labeling, this one's a little bit more complex. So this computes the z-score of each resume's keyword score, which I talked about earlier. And a resume is labeled fit if its z-score is greater or equal to 0.5. So this method obviously adapts based on the distribution of scores across the entire data set. And the histogram of z-scores is plotted to a visualized threshold impact, and you're going to see the histogram when I run the code in just a minute. And the z-score was basically computed by taking each resume's keyword match count and subtracting the average keyword count across all resumes and dividing by the standard deviation. And I know that sounds like a lot, but this is the mathematical formula for it. So the z-score is basically the keyword score minus the mean keyword score divided by standard deviation. So this basically just tells us how far a resume's keyword count is from the average in units of standard deviation. And this helps us identify resumes that really stand out because this is, like I said, for like a big company looking to hire interns. So it's a more competitive kind of resume screening process. So we chose a z-score threshold of 0.5 to select resumes that have keyword scores at least half a standard deviation above the mean, indicating above average relevance without being overly restrictive. So yeah, to quickly talk about the output of each notebook. So each notebook trains and evaluates a logistic regression model. It also prints the classification metrics, specifically precision, recall, and F1 score. It displays each resume's final decision. So we've commented this at the moment because it's obviously a very long printout, but if you don't want your results saved in the CSV, that's another cell on the bottom. You can just comment out that cell and just have this function uncommented, so you can just run it, and you can just print out that output within your notebook instead of exporting it as a CSV. And we just want to make sure that before you run your code that your resume dataset.csv and your keywords.csv are both in the same directory. So yeah, that's about it for like a basis of our project. Now I'm just gonna walk you through the code to some important parts. So obviously, before you run the notebook, you want to be sure to install the required libraries using the pip install command. We've already added that for you. We also have the import libraries, and you're going to need all of them to be able to run the notebook successfully. Okay, so let's talk about the keyword score function. Basically, here we score each resume based on how many keywords it contains. If it contains 3 or more keywords, we consider it a good fit. This threshold is an example. Is simple and easy to change. I was gonna say it's an example of like an adaptable function, but yeah, depending on your specific company requirements, this is customizable. So for the training part, we now vectorize the text and train a logistic regression model to classify these resumes, and this gives us a decision for every resume, which we print or save to a CSV. So like I said, it's commented. You can prefer what mode you'd like. Right now we have it set so that it exports to a CSV, so we have every single output, and it's just cleaner this way. So moving on to our z-score model, this is obviously the more statistical model. We use a dynamic threshold based on z-scores. So let's talk about just the z-score labeling part. This is basically where we say a z-score of 0.5 means the resume's keyword score is at least half a standard deviation above average. And this is just a really smart way to filter the top candidates. And here's the visualization part. So this histogram shows where resumes fall in the distribution, and it highlights our specific threshold. So yeah, just to quickly touch upon when to use which again. If you're hiring in bulk, like a startup, like I said, we recommend you use the rule-based model. And if you're hiring selectively, like interns or high impact roles, we use the Z Score model. So that's kind of what our thought process was when we built two models instead of one. And yeah, that's about it for our demo. Thank you so much for watching. And we hope it helped you understand how NLP can streamline resume screening. And that's kind of, we were both new to this before this project, so we learned a lot about NLP and machine learning and obviously data analytics. But yeah, check out the GitHub repo link for the full file list and the README that I just read off of. And yeah, thank you so much for listening.